So, friends, good morning, everyone. We are going to discuss about some important topics related to concrete technology. What are those important topics? I will be discussing all of them to you. Okay. Now, what is concrete? What do you mean by concrete? Concrete is a mixture of cement, sand, and aggregates. Cement might be of different types. Sand is earlier it was used as M sand or NO sand, but now it is used as crushed stone sand. And aggregates, there are many aggregates which we can use. Aggregates are like fine aggregates and coarse aggregates. Fine aggregates are known as sand only, and coarse aggregates are the bigger boulders or gravels which are made up of the disintegration or decomposition of the rocks. So this is what about concrete that I would like to talk about here. Now, there's a term called civil in civil engineering. Civil is known as something which is non-military, and how civil came into existence. The civil came into existence when there was nothing constructed. Humans were living inside the caves. Humans were not humans. They were, you can say, humans were not humans. So the humans were not humans. They were almost, you can say Adi Manav in Hindi, Adi Manav. So Adi Manav, when Adi Manav was there, it was only caves and bushes and the oldest civil engineer. Which is the oldest civil engineer? Which is the oldest civil engineer? Can you say it? The oldest civil engineer is a beaver. What beaver used to do is, beaver used to create tunnels inside the ground in jungles. So he's referred as the oldest civil engineer in the world. Now, I am reading this book, which is A.M. Neville, and it is Properties of Concrete, the 5th edition. So I'm reading this book and I'm explaining each and every topic to you. First, what we'll do is, we will read the preface. In preface, what is written? Concrete and steel are two most commonly used structural materials. They sometimes complement one another and sometimes compete with one another so that structures of a similar type and function can be built in either of these materials. And yet the engineer often knows less about the concrete of which the structure is made than about the steel. Steel is manufactured under carefully controlled conditions. Its properties are determined in a laboratory and described in a manufacturer's certificate. Thus, the designer need only specify the steel as complying with the relevant standard, and the site engineer's supervision is limited to the workmanship of the connections between the individual steel members. On a concrete building site, the situation is totally different. It is true that the quality of cement is guaranteed by the manufacturer in a manner similar to that of steel, and provided suitable cementitious materials are chosen. It is hardly ever a cause of faults in a concrete structure, but it is concrete and not cement that is the building material. The structural members are more often than not made in situ, and their quality is almost exclusively dependent on the workmanship of concrete making and placing. The disparity in the methods of steel and concrete making is therefore clear, and the importance of the control of the quality of concrete work on the site is apparent. Furthermore, as the trade of a concreter has not yet the training and the tradition of some of the other building trades, an engineer's supervision on the site is essential. These facts must be borne in mind by the designer, as carefully an intricate design can be easily vitiated if the properties of the actual concrete differ from those assumed in the design calculations. Structural design is only as good as the materials used. From the above, it must not be concluded that making a good concrete is difficult. Bad concrete, often a substance of unsuitable consistency, hardening into a honeycombed, non homogeneous mass, is made simply by mixing cement, aggregate, and water. Surprisingly, the ingredients of a good concrete are exactly the same, and it is only the know how, backed up by understanding, that is responsible for the difference. What then is good concrete? There are two overall criteria. The concrete has to be satisfactory in its hardened state and also in its fresh state while being transported from the mixer and placed in the formwork. The requirements in the fresh state are that the consistency of the mix must be such that it can be compacted by means desired without excessive effort, and also that the mix be cohesive enough for the methods of transporting and placing used so as not to produce segregation with a consequent lack of homogeneity of the finished product. So this was the preface of the A.M. Neville. There are two more pages, so I'm going to read those two more pages in my next lecture. Till then, it's a goodbye and thank you.